Are we live? We're live. Now, a couple things that I wanted to show you. Unfortunately, the website was called 29 Gifts That Teach You Math Better Than Your Teacher Did, which is not true because I'm teaching you this. But there's a really cool one here, how to drill a square hole. You can see that triangular shaped bit. I don't know what I'm looking at. Hopefully you can see that there. The original website, it was nice. Maybe I'll have to create a better one. But the other thing that I wanted to show you was making a parabola. How to create a parabola, okay? You get your focus, your directrix, you take a midpoint, and then that line is perfectly in between both of those points. How about that?
So it's like the pencil of the string thing.
Yeah, kind of. So you got your focus, your directrix, you go to the midpoint, and then you keep it as the midpoint between those points all the time. Notice you have a right angle on your directrix at all times. Okay? Wow, pretty cool. And hopefully this is being on the video because I can't see. Then we have making an ellipse. I think I mentioned this to you. Oh, that one's busted. Sorry. Reflective properties of an ellipse. That one's, oh, that's terrible. Oh, hopefully it's not out of focus.
They got the gist of it. They should be.
The hyperboloid. This is a cool one though. Okay, do you see that? What does that look like? What? So that's a hyperboloid, they call it. It's two hyperbolas. Do you see on the sides it looks like a hyperbola? It's drawn with a perfectly straight line. But what in life does that look like? A nuclear reactor tower, cooling tower. That's exactly what that is. That's why it's the shape it is because it's a hyperboloid. A couple of hyperbolas because it cools things better for some reason. Okay? A nuclear reactor tower?
You know, have you seen The Simpsons? The one that was.
No. Sorry, I will have no idea what it is.
Okay.
Oh,
Cooling towers. There you go.
Weird. So why
Oh, brother.
You don't want to show it. You're going to get demonetized. You're showing another YouTube video.
No, we're reacting to it.
Whatever, you saw that. Here, we'll just go back.
We got to change your channel to Math React.
Yes, that'd be funny.
So anyway, you got your nuclear tower. Here, we'll go to images. There you go. Those are nuclear towers. They're in the shape of hyperbola. I don't know why they do that, but anyway, they do. It's better for something. I'm not a nuclear scientist, so. The other thing that I wanted to show you was that the hyperboloid is made out of straight lines. I already showed you that one. But here, look at this. We've got a straight bar.
Oh, it's going through that.
It's going through the, see that?
Oh,
That's just a straight line.
wait, that's cool.
Isn't that amazing? All right. So there used to be a website. This is not the correct website. There's some other stuff in here.
We're not locating pi.
I will show you this because this is kind of cool. Let's see. This is kind of cool. How to round your circle. Do you realize that book? If you move it around those three weird shapes, that it's just like as if they were on circles. Anyway, this used to be a cool website, Distractify, but it apparently no longer exists. I'm kind of glad that I pasted it here, but you got all that stuff there. The problem is none of them are GIFs, or GIFs, I don't know. There's some other stuff on there too. I'm gonna have to oh, this one's kind of cool. A squared plus B squared equals C squared. If you rotate that, then the A and the B, the water, goes into the C side. It's kind of cool. Anyway, you should see it when it's in motion. Oh, and then this one's goofy. Have you seen this one? It says 4 by 4, and then he writes on equals 16. Anyway, sorry. Love the bow tie. Oh, and have you seen this one? If you erase the top of this here, it says I love you. Oh, nice. Anyway, it's time to get back to what we were talking about.
We're having fun.
We were having fun. Okay, all right. So now let's talk about shifting our conics. We're going to do some shifting. Shift happens. All right. 7.4. So let me ask you, I'm just going to do some things here, and you tell me what you think. So if I have x plus 1 squared divided by 4 plus y minus 2 squared divided by 9 equals 1, first of all, can you tell me what is that? It's an ellipse. Why is it an ellipse?
Because it's plus.
You've got a plus and it equals 1, right? Okay. All right. So the idea here is we've shifted this. No, it's no longer the origin. So if you were to guess where the center would be of this ellipse, where would you guess that the center would be? Negative 1, positive 2. So negative 1, positive 2. That's my new center. Okay? So now, in the x direction, where am I going from there? I'm going left and right 2. So 1, 2, 1, 2. In the y direction, where am I going? Say it again?
Up and down 3.
Up and down 3. So I'm going 1, 2, 3 in the upper direction. 1, let's see, we got to start here. 1, 2, 3 in the lower direction. I'm going to move that because I think I'm off my scale there. Okay? So I've got an ellipse here. Now, let's talk about where's your vertices, your foci, your center. We'll do our eccentricity. What else do we need to know? That's good enough, I guess. So the center, we'll do the center. What's your center? Negative 1, 2. Okay. Now, this is why I think graphing it makes it a little bit easier, because now let's talk about your vertices. What is this vertex right there? Vertex. Negative 1. So I've got negative 1, 5. What's this one?
Negative 1, negative 1.
Negative 1, negative 1. What's this one?
1, 2.
1, 2. And this one is?
Negative 3, 2.
Negative 3, 2. Okay?
This one you have to write them all out.
This one you're going to have to write them all out because there's
Do you
no.
just put them like all next to each other like that? Is there a certain form you want?
That's fine. Look at that. I'm not worried about the order as long as you have all 4 of them. Okay? All right. Oh, actually, let's do your major and your minor axis. We'll add those on there in a minute. Actually, let's do those now. What is your major axis in this case? No, it's not. It's no longer the y-axis.
It would be negative 1, 1.
It's this line right here. This is your major, right? This is your long one. So what is the equation of that line? X equals negative 1. What's the minor axis? Y equals 2. Okay? So we're no longer at the origin anymore. Your foci. Where are your foci? What is it?
Would you still do the same?
Same as we did before. Okay. We're going to have to find our c squared, right? C squared is 9 minus 4, right? It's the big number minus the small number. Okay. So c squared equals, so rather c equals plus or minus square root of 5. Okay, so see, so it's always on the major axis, correct? So that's a little more than 2, right? So if I go up and down 2, a little more than 2, so it's right there. And if I go 1, 2, it's right there, correct? What are those two coordinates?
-1
-1, comma,
plus or minus. Wait, no,
It could be plus or minus.
we're measuring everything from the center, right?
yeah.
So from the center, you're going 2 plus or minus the square root of 5.
Oh, okay, yeah, okay,
Okay, so you can write that one that way.
okay,
Okay, does that make sense?
yeah.
Because we're measuring everything, we're going up the square root of 5 from here, down the square root of 5.
It's,
That's gonna be a nice one, huh? That'll be a fun quiz tomorrow.
What did you ask?
You get a fun test tomorrow?
What's that?
That's all the test is about?
Oh, wait, yeah, today's not.
Today's Tuesday, right? We still got a quiz tomorrow.
Oh, yeah, quiz.
Okay, does that make sense?
Today's Tuesday, not Wednesday.
What's your eccentricity?
C over.
Would be the same.
9.
C over the big number, right?
Yeah.
So C is
Square root
square root of 5
over 3.
over 3.
Do you square root the big number, or when you do the eccentricity?
So C squared is 5, so C is the square root of 5. So I just leave it as square root of 5, that's fine.
I know, but over 3, like would you square root the big number?
Square root of minus 3. I'm not sure what you're asking.
So in the equation, it's like b squared, because b squared.
I'm just, yeah, I always keep running it as like just a bigger number, RD squared, or RD, yeah.
Okay, so it sounds like you're mixing up B and B squared. Remember, I don't know how. Remember, eccentricity is C over the big number squared. Or just not the big number. Big number not squared.
Yeah.
Okay? Length of your major axis is? Victor? Length of your minor axis, Victor? 4. Okay, is there anything else I can ask about those? About an ellipse?
I'm sure there is.
I'm trying to think of what I'm missing. I think we got most of it. Okay. All right, how about, okay, let's go on to another one here. What if I tell you the vertices of an ellipse are -7, 3, and 3, 3. Foci are at -6, 3, and 2, 3. Graph and find equation of ellipse. What do you think, Cameron? Cameron Indoor Stadium.
graphic.
Are you a Duke fan, by the way?
What?
Are you a Duke fan?
No, what?
Because you're named after their basketball stadium.
I don't even follow any sports.
No. What's wrong with you?
Nothing.
All right. So graph it. What are we doing?
You're gonna put the vertexes in there first, so 7 or
So
negative
-7. 1, 2, 3, 4, 5, 6, 7. And up 3. 1, 2, 3. And 3, 3. 1, 2, 3. Okay. Now I've got a foci at -6 and 2.
And then you gotta find.
Now we don't know how up and down it goes, right?
Yeah.
Okay. So far that's all we can graph. Now what? Don't know. What's the general equation of an ellipse?
Isn't it x over 2 or x squared over
over
A.
something, we'll call it A and B, I guess it doesn't matter. A squared plus y squared over b squared equals 1. Can we fill in anything?
We can do, yeah, change x squared to -7. X. Oh, wait. What am I thinking?
A squared is 20.
Probably would be nice to find the center, wouldn't it? Can we find the center with what we know yet?
Oh. So if you take furthest.
We know this is the major axis, correct?
Right.
How long is your major axis?
Yeah, 10.
10. So where's the center?
5.
It's in the middle, it's 5. So if I go 5 units from here, 1, 2, 3, 4, 5. I just found the center, and just to make sure, 1, 2, 3, 4, 5. That's definitely the center. Okay? So the center is where?
-2, 3.
-2, 3. Okay, so now I can substitute that into these two, into the numerator, right?
Oh, yeah,
So this becomes
-2 squared.
x.
Oh, we're substituting it.
Yeah, but remember the center goes into numerators.
Yeah, that's what it's doing.
Okay, so say it again.
There's -2x, or -2 squared, right?
-2 squared? We want it to look like this.
Oh, or x minus 2 squared.
Yeah, x plus 2
So
squared.
do the opposite.
You do the opposite.
Okay.
Plus
Y minus 3 squared.
squared. Okay, now, do we know which one's the big number? And do we know what the big number is?
Yeah.
We do. Do you know,
No,
Cameron?
how do you do?
How do you know? Berkeley?
So.
What's the big number?
Oh.
You
From the
just said it,
center,
by the way.
from the center, it's 5 away.
5 away, right?
So then it's 5 squared.
So it's 5 squared.
Oh.
You found this distance was 5,
Alright.
so it's 5 squared, which is
5 squared.
25. Okay, and it's in the x direction, so the 25 is the big number, right?
Yeah.
Do we know the small number?
No.
Not yet. Equals 1. So we're really close on getting this. How do we find that small number?
A squared minus b squared.
What'd you say?
A squared minus b squared equals c squared.
Ah, there we go. We got a squared minus b squared equals c squared, or actually the big minus the small, right? So this is going to become 25 minus b squared equals, what's c squared? I heard somebody say it, but it wasn't
Yeah, I can find
Cameron.
that at 16.
How did you find it was 16?
Well, you know what, that the foci
The
are.
foci is c squared, is c, right? What's c?
Wait.
No.
Oh.
This is 5, what's this?
4.
4, and that's because the c is your distance to the foci, correct?
Oh, okay, yeah.
So c squared is
C squared.
16. 4 squared is 16. Okay? So now I'm going to subtract 25 from both sides. And I'm going to get negative b squared equals negative 9. So therefore b squared is 9, which is all I need. That was a fun one.
Yeah.
Okay? You going to ace my quiz tomorrow?
Maybe. Let's see.
Maybe. Okay. All right, so we found the equation of the ellipse. We have not finished graphing it. How far up and down am I going?
3.
Going up 3. 1, 2, 3, down 1, 2, 3. So I'm going to be on the origin. I'm going to here, and I'm going to here.
I'm so bad at drawing circles.
Well, I hope you should be much better at drawing ellipses than circles, right?
Yeah, they all look like.
Most of your circles look like ellipses anyway, right?
Really square. Yeah.
Okay. All right, so we finished drawing it. Let's tell me where the vertices are. This isn't part of the question, but why not? Okay, where are the vertices that I want for the answer?
You already have 2 of them.
Yeah, so the other, we've already got 2 of them. What are the other 2?
The other 2 is our -2, 0.
-2, 0.
And
Are we off the page? There we are.
-2, 6.
-2, 6. Okay. Is there anything else we can ask? I know that Caitlin likes to ask what the eccentricity is. Is that just because you're an eccentric person?
No, it's just something that I knew was gonna be on the quiz.
Okay. What's the eccentricity?
So it's C over the big number, correct?
Correct.
So
C was, did we ever say what C was?
C is
C
4.
equals 4.
So it's 4 over 20, or 4 over 5, my bad.
5, right? 'Cause that's your big number.
And you just leave it like that, it doesn't get shifted or anything.
No, it doesn't get shifted out. That's still your eccentricity. Your eccentricity doesn't matter where you are on there. Okay?
What exactly is?
So that's almost kind of like a scale.
The ovalness of it. Closer to 0 would be a circle. Closer to 1 would be a straight line. Okay? So this is more oval. Okay? All right, we ready for another one? Guess we got to erase some stuff now. All right, so let's go with this one. X squared minus 4x equals 8y minus 28. Before I ask you any more questions, what is this shape, Hunter? Good question. Good question. Not really so. It's a hyperbola because? Because what?
It has a minus.
Because it has a minus, it has 2 minuses. I don't know if that's a good giveaway.
Doesn't it need to be a y squared parabola?
Yeah.
In order to be a hyperbola, it would need to have a y squared. It doesn't have a y squared.
Is that just a parabola then?
Ah. Do you see that that's a parabola and not a hyperbola? Yes, because there's no y squared, so now it's a parabola. It's a parabola in which direction? Opening up, right? I've got a y equals an x squared, right? So it's going to be opening up. Okay? Now it's going to be shifted though, right? Because this whole section is about being shifted. Okay? So, ideally, I would like this to be in some sort of an x minus something squared equals some number 4p times y minus something squared. Okay? Does that make sense? Okay.
Factor.
So how can I turn this? I mean, I could pull out an x, right? But that wouldn't really help me. How could I turn this into looking something like that?
Could you just square both sides?
I could square both sides, but that would make my life really hard. And it would turn it not into a parabola anymore.
You just put the square on the outside and bx minus 2.
I could, but that wouldn't be helpful.
Would you want to add the 28 that's on and then factor?
I would leave the 28 alone for now.
Could you?
Would you want from?
You guys remember how to complete the square?
Are we trying to do perfect squares? So we're looking at
That would be nice. If I complete the square here, okay, So if I have, I'm going to rewrite this as x squared minus 4x, and I'm going to give myself a big blank equals 8y minus 28. What could I add so that I could factor it into something like that?
Would it be 2?
I could add 2 squared, right? Okay. And if I did this, this would factor into what?
X.
X minus 2 quantity squared, right? Okay. Now, because I've done that, so I've added 4 to this side, but that's not legal unless I do what?
To the other side.
I need to add 4 to the other side. Okay. So this makes this 8y minus,
Yeah, it's 32.
no, 24.
Oh, sorry, that's a negative 28. Yeah.
Okay. Now, can I factor this? Okay, what does that factor into?
So you
8 times
y minus
y minus 3 equals x minus 2 quantity squared. Okay? Now, where do you think the vertex is? Ethan, what do you think?
Plus 2.
2, 3, that would be correct. 2, 3. It's the opposite of both of those signs, right? So now I'm at 2, 3, so positive 2, positive 3. Which way does it open? Opens upward, okay? We'll get to see how, now we need to find the focus and the directrix. How do we find those?
P, right?
Find P, what's P?
It's 4P equals 8.
4P equals 8, so P equals
Equals 2.
2, okay? So I'm going to go up and down 2, right?
Yeah.
So if I go up 2,
That's the focus.
that's my focus, and that coordinate is?
That's, is that 4 or 5?
1, 2, 3, 4, 5, right?
Okay, so 2, 5.
2, 5. My directrix is
And then you go down to,
down 2.
so is it 2, 1? Versus the line?
Is it 2, 1? To the line, isn't it?
Oh, so it's 2, 0? Oh, it's just, oh, it's the axis, the line, the x-axis,
Y equals
0.
1. This is your directrix right here, right? Okay? Now, let me ask you a question. Would it be easy to, if x was 0, if x was 0, what would y be? (8y) would equal 28, right? Divided by 8. Y equals 14 over 4, which is 7 over 2. So it's about 5.5, right? So I could find that relatively easy. So 1, 2, 3, 4, 5.5, about right there. So that was a pretty easy point to find. So I'd probably like to find that point. Okay? Yes.
I just have a question. We have, when we were trying to take it into that second step that you did, you have equals 4p times y minus something squared.
Are you
Is it
just
not
meaning
supposed
if
to
it
This
was
is
a
not
line?
squared.
It's not squared.
So,
You squared it up top.
yeah, is that just if?
Oh,
it
you're
was a
right. I
line
didn't mean to
square?
square that. Yeah, that should not be that. Yeah. Sorry, I was too into ellipses. I thought I'd square it. Okay, does that make sense? Okay. All right, so we found our focus, we found our vertex, we found our directrix. Is there anything else to find with those? I don't think so. Okay. What'd you say? Oh, axis of symmetry. Thank you. How did I forget that? What's your axis of symmetry?
X equals 2.
X equals 2. This is where we're symmetric. Okay?
Oh, never mind. No.
You said I told you, and then you're like, what?
No, when you wrote, when your hand went down the board, for some reason my Mine thought you drew the axis line. So I saw you draw the line way off center. I'm like, that's not the line.
All right, we good? Okay. All right, how about, oh, I like this one. Might have to make this a test question.
Okay.
All right, let's see here. I've got 9x squared minus 72x minus 16y squared minus 32y equals 16. What could it be? It's definitely not a parabola. It could probably a hyperbola, because why? We haven't talked about it yet, right? Or what else could it be? Could be a circle, could be a hyperbola, or an ellipse.
So you have to find out if it's subtracting.
But it's probably shifted, whatever it is. Okay? So best guess is it's probably a hyperbola or an ellipse, right? In either case, what should I do?
You want to get a 1 on the side.
I want to get a 1 on the other side, but this is also shifted, correct? So I don't want to get a 1 there yet, because if I put a 1 there now, it's probably going to change. Okay? So let's see if we can do some completing the square on those two. Okay? So I could easily factor out a 9, and I'm left with
X squared minus 8.
x squared minus 8x. And I'm going to leave a gap there, so I'm going to complete the square. And I can factor out a minus 16 out of here, right? And I would be left with
Y squared plus 2y.
2y, and I'll do a gap, equals 16. Okay? All right, so now, Jonathan, how do I complete the square on this?
You could add.
I'm going to take half of 8, right? What's half of 8?
4.
I'm going to add 4, and I'm going to square it, right? Now, I've just, 4 squared is 16, but I'm actually multiplying that by 9. So 16 times 9 is 144, because we did that yesterday in class, remember?
Oh, yeah.
So I'm really adding 144 to this side, right? So I'm going to add 144 to that side. Okay?
Oh, buddy.
Now we're glad we didn't worry about that 16 yet, right? Okay, so now, Bailey, can you complete the square on this?
Yes, so that would just be 1 plus 1.
1 squared, right? Okay, but I'm multiplying that by negative 16,
So we're just adding.
so I'm really subtracting 16, right?
Now we
Which
get
means I can subtract 16 again.
So those
Those cancel, isn't that nice? All right, so this factors into what, Bailey? Can you factor that?
Yes, so that is x minus 4. Yes.
Squared minus 16 times
X plus 1. I mean,
y plus 1 squared equals 144. Wasn't that a nice number? Now what?
Now you get a 1.
Now we want to get it to be a 1. So how do I get it to be a 1? Divided by 144. It wasn't this really well put together problem. This one you can tell was engineered to end up being a nice problem. I've got 1 here. 9 goes into 144 16 times. 16 goes in 144 9 times. What a nice problem this was. And what is it? It's a hyperbola for sure now, right? Okay. So because it's a hyperbola, what's all the information I'm going to need?
Where it's shifted.
I'm going to need the new center, which is
It's 4, -1.
4, -1. What else am I going to need?
You'll need the vertices.
The vertices. What else am I going to need?
Okay.
Foci.
And the transverse.
Transverse axis, right? And asymptotes. See, this would be good. I'll be like, okay, I'm going to give you this problem. Give me all the stuff I need, and then you have to come up with what you need. Yeah, that's what I'm talking about.
Graph.
Okay. Dino, what do you want to take over on this one? Oh, and graphic. Yeah, we better not forget that. That goes without saying, right? You guys are going to be so good at graphing when you get in your calculus class, you'll be like, hey, I can do ellipses, parabolas, bring it on. Logarithms, exponentials. You're going to be like, your teacher's going to be so impressed with you. You're like, wow, who's your college algebra teacher? Okay? All right, so what are we doing now? Let's do the graph first, right? Because Dino's a good grapher. Oh. So the center's where?
4, 3, 1.
4, -1. 1, 2, 3, 4, -1. That's my center. We're measuring everything from there. Okay? I'm going to go up or down or left or right. I don't know, you can pick. I don't care. Which way? Sideways, well, how many? Four, that's correct. 4 in each direction. So 1, 2, 3, 4, I'm here. 1, 2, 3, 4, I'm here. Now, is that the transverse axis or no?
Yes.
That is the transverse axis because the X is first, right? So I'm going to just draw this just so I don't get screwed up later. Okay? Now we're going up and down. Nope.
Oh, wait, so
3. We're going up and down 3, right? Okay? So I'm going to go 1, 2, 3, I'm here. 1, 2, 3, I'm here. Now what am I going to draw?
you were asking so. No, square. Okay.
You were drawing a square, right? So draw our square. Okay, and we can draw our asymptotes through the center, right? In the corners. Okay, so now I can finish this. It's going to look something like that. Okay? All right, so that's the quiz tomorrow, okay? So, can you tell me where the vertices are? Do you know? It's right here and right here, correct?
Yeah.
Those two coordinates are 0, -1, and 1, 2, 3, 4, 5, 6, 7, 8. 8, -1. Okay? All right, whose turn is it now? Juliet, I haven't picked on you today.
Oh, that's a shame.
What a shame. What do you want to do next?
Oh, let's do foci, right?
Let's do the foci. How do we find the foci?
Do the whole C squared, wait, yeah, right?
I didn't hear what you said.
That's the like A squared plus B squared, yeah.
A squared plus B squared equals C squared, okay? So we're going to get,
So it's 16.
16 plus 9 equals c squared. That was nice. So c equals plus or minus 5. So that was really nice because I got a nice number, right? Okay. So my foci are plus or minus 5. So if I'm here, 1, 2, 3, 4, 5. I'm here, 1, 2, 3, 4, 5. What are the coordinates of those 2 points?
-1.
Oh, me?
Yep.
Okay. It's -1, -1, right?
Okay.
And then negative, or wait,
Oops. Yeah, it's not -1, is it?
no.
This is 1, 2, 3, 4, 5, 6, 7, 8, 9.
9.
-1. Okay. What's your transverse axis?
That would be the
That's this axis right here.
x-axis.
It's not the x-axis.
Oh,
It's shifted, right?
Oh, it's, isn't it like y equals -1?
Y equals -1. Okay, now, if my asymptotes were not shifted, Caitlin, what would they be
If they weren't shifted,
if they were not shifted?
it'd be b over a, correct?
Yeah, y equals plus or minus b, which is
9 over 16, or 3 over 4?
3 over 4
Okay.
times x, right?
Uh-huh.
Wait, I thought it
But
was-
we've shifted.
So would it be the -4?
So the x would be -4, and the y would be,
-1, or +1, sorry. Right? Oh, +3? -3?
y minus 3. I'll put it in parentheses so that you know it's opposite.
Okay. Oh my gosh.
So this is good enough for me for the asymptotes. Okay? We've shifted it to the new center, which is 4. Let me make sure, is that right?
Would you just do the y plus?
Yeah, it should be -1, I think. You're right. Yeah, we gotta break it with the center. Sorry, you're right.
Okay.
I was thinking it was this, but it's the center. Y -1. Okay, y -1 equals plus or minus 3/4 times x minus 4. Because we're basing it off our new center, not off the origin anymore. Okay?
So yeah, how can we have +4 as the center and then it's negative?
Because remember, we always put it in parentheses. It always goes with the opposite.
So then wouldn't it be
So
y
yeah,
plus 1?
why be +1?
Yeah.
Yes, it would.
Okay, so basically you just pull what's in the top over there.
Yeah,
to
flip it
that.
around. Sorry.
Flip the center.
I'm rusty on this one. Okay? 3 yesterday. We're only going to get through 1 today.
So
Crap.
can we do the test question now that we had on the test?
Well, we could, but not on camera.
Oh,
want me to
sure,
turn it
we'll do
off?
the test question.
Because I think, am I done? Oh, I want to do one more. If you want to stick around, we'll do the test question. But I like this one because it's a good one. Okay? All right, here we go. I've got 9x squared minus y squared plus 18x plus a 6y equals 0. What do you think it might be?
Hyperbola.
Probably a hyperbola because I've got an x squared minus a y squared, right? So if it's anything, it's going to be a hyperbola, probably, right? Could be an ellipse, but probably a hyperbola. Okay? So what would we do next?
You get the like terms.
Get the like terms together. So I'm going to have, I'm going to take the like terms together, And I'm going to factor them as I go. So this becomes 9 times x squared plus 2x minus y squared minus 6y equals 0. Right? Everybody with me so far? I know we're short on time. Okay, so how would I complete the square, Victor?
It goes to a 1 squared.
So I'm going to add 1 squared here, but I'm really adding
9.
plus 9. And what do I do here?
So negative 3.
So I'm going to add, actually, 3 squared. So I'm really subtracting 9. Okay, so this becomes 9 times
X plus 1.
x plus 1 squared minus
Y plus 3.
y minus 3 squared equals
0.
0. It doesn't equal 1. And I can't do anything to make that equal 1, can I?
It's illegal.
So that's a problem.
Well, there's a minus 1 right there.
There's no solution.
This is what we call a degenerate conic.
You
degenerates.
What does that say?
Conic.
Can we just put DC?
I'd like you guys, you like that word, right? Degenerate? It's like latus rectum.
I can't spell it.
Okay. So, so here's the interesting thing. Let's go ahead and let's add y minus 3 squared to the other side, to both sides. So this becomes 9 times x plus 1 squared equals y minus 3 quantity squared. Okay? So therefore, what would you do next? You could take the square root of both sides. And get 3 times x minus 1 equals y minus 3 plus or minus, right?
Wait, is it x minus 1 or x plus 1?
Plus 1, sorry. Okay? So this becomes, so we got 2 equations here, right? 3x plus 3 equals y minus 3, or 3x plus 3 equals minus y minus 3, correct? Okay. So now, if I add 3, I'm going to get y equals 3x plus 6, which I can graph, right? That's just a straight line. And over here, let's see, minus minus, I could make this, here, I'll distribute it. Negative y plus 3 equals 3x plus 3. The 3's are going to cancel, right? And I could get y equals minus 3x. Do you see that? Can you graph those 2 lines? Did you remember how? Y equals negative 3x is easy, right? It goes from its origin. What does it look like? We're going to rise negative 3. We're going to run 1. Ooh, that was terrible looking straight line. Okay? And this goes through 6, right? 1, 2, 3, 4, 5, 6. It's going to rise 1, 2, 3, run 1. there we are. Degenerate conic turned into a couple of straight lines. Okay. So that wasn't too bad.
If we get that, do you want us to turn it into two lines? Or
Yeah.
just,
Yeah, you can go through this. The degenerate conic turned into a couple of straight lines. Okay, they equal each other right there, which, if my graph is correct, is about 1, 1. 1, negative 1. Negative 1, 1. Sorry. Okay. All right. So, dang it, we did 3 yesterday. We made up for it today. We only did 1 section. So, quiz tomorrow.
We gotta do 3 tomorrow.
Yeah, we keep it up. So, quiz tomorrow is going to be on 7.4 because we didn't get to 8.1. So, see you all tomorrow.